Okay, in this video I want to show the use of a couple of tools that I don't think are very commonly used in Meshmixer, and that is the join tool and the bridge tool. I'll show you why I like these tools, and I think you'll find a lot of uses for them as you start to play with them. This is a case where patient needs an upper denture, and so for starters we need to do a record base. This is where extractions will be done, and so you really need to make a record base that just kind of goes lingual to these anterior teeth, and let's try to make that record base just be 2 millimeters in thickness. So let's start that by going to the select tool, and what we can do is just outline the perimeter of where we want this record base to be. So you can color in all of the areas in this portion pretty quickly, but you want to be pretty specific with your perimeter out here and take it exactly to the border of where you want this record base to go. So getting right to the depth of the vestibule, something like that. That should be good. If you need to erase anything where it's overextended, remember, hold your shift key down and just left click, and you can use that as an erase tool. Alright, so here's our perimeter. I always start by optimizing the boundary and then going back and smoothing the boundary, because all of the tools tend to work better if it's got a smooth boundary to start with. So let's start this process by going up to Edit and Offset. So anytime you're making a base on a physical model and it has to be able to come on and off and seat precisely, you want to build in an offset. So you don't want an absolute dead zero surface because it won't seat on that stone model. So in this case, I want to do about the same as what I do with the surgical guide. I'm going to create an offset of 0.3 millimeters. That's enough that it will have the tiniest bit of play where it can fully seat correctly on your maxillary model. So I've got a 0.3 offset. If I zoom in here, you can see that offsetting is exactly as the name would indicate. It creates a tiny bit of a gap between the model, and you can kind of see it right there. Okay. Now, while this is still orange and all selected, I'm going to go up to Edit and Separate. And all that does is it turns it into its own STL. As you notice here, this is not an STL that you could print currently because it's just a one-sided skin. And so historically, the way I've always done this is to now come in and extrude this. You could select it all, go to Edit, Extrude. And if we gave this a thickness of, let's say, 2 millimeters and updated it, you can see that the problem with the extrude tool is that you get a lot of really rough boundaries right here and lots of areas where the mesh crosses over itself, and that means you now have to spend time with the smooth tool and smoothing all that out. It's just a lot of unnecessary work. So instead of doing that, let me show you how I'd use the bridge and the join tools to update this. Alright, so what I'll do is select this entire thing. I'm going to go up here and offset this again. Now this time, the amount of offset that I want to use is whatever thickness I want to create this base to have. So let's go with 1.5 millimeters of thickness and update it. And now when you accept that, you're going to see that you've got two shells here, but they're not connected. This is still not a printable object. So what I do with this second surface is I'm going to go in and just select its boundary. The bigger of an offset you do, the more you'll end up with a tiny bit of roughness right here on this boundary. So I'll select that boundary by double clicking the blue line. I'm going to expand the ring a time or two, and let's smooth that boundary to get rid of any of this rough surface right here. I can accept that. And here's the result again. Two shells separated by 1.5 millimeters, but still not a 3D object. So what I need to do here is I'm going to flip the mesh on this lower surface inside out. I do that by clicking it all and then Edit, Flip Normals. So now you see it looks a lot more like what a record base would look like. It's got an inside surface and an outside surface, but still not connected. Okay, so let me show you the two different ways that you could do this using the bridge and then the join tool. So first of all, if the goal is to turn this into one solid three-dimensional object, I could take the select tool and let's just select a small portion of this boundary. And now I could go and hit bridge. By bridging that, you see that now this connects the two of them. Now, if I do that in one other area, then essentially what I've done is created two holes that are fully bounded on either side, and the software could just repair them. So let's do one more here. Edit, and here you see that it has closed that. So again, now if you were to run the analysis inspector, what you would see is that there's going to be just two individual holes. Okay, this is a hole, this is a hole, and now if you just let it repair, the software will repair all of those. And there you have it. So this is one great option. This would be a good record base, no edges to smooth out like you would have had to using the extrude tool. So that's option one. Now I'm going to hit Control Z a few times and undo all of those things and get back to where I just had the two shells. All right, now we're back to just two separate shells. Here's the other option that you could do. You can go up here and with the small selection tool, let's just choose both of the boundaries by double clicking on the blue line of each shell. Here you see that we've selected the entire boundary all the way around. Not a bad idea to go ahead and optimize the boundary and smooth the boundary again. Like I mentioned, it's just always a good idea to do those things because all your tools just seem to work better. So you see the perimeter is selected on each shell. Other option is you could come up here to edit and this time join. Now this is going to take both of those boundaries and just weld them together. Okay, so again, much quicker and a much smoother boundary that you're not going to have to go back and smooth on. And so I think you'll find a lot of uses for this, not only in creating record bases and guides and different surfaces like that, but oftentimes you'll also have holes in your model that you need to correct. Maybe you've missed with your intraoral scanner a deep part of the vestibule and you don't want to have to trim all that away. So what you could do is just bridge that boundary. Now, one other use that you might find the bridge tool helpful on is repairing intraoral scans. So this is not uncommon at all to get an intraoral scan that looks something like this. Just oftentimes, especially in the movable tissue boundaries, you're going to get just lots of noise and distortion, things like this, and that all has to be repaired. This obviously is not a printable object, so I'm going to first start out by just getting rid of some of these really rough edges by deleting them. Okay, so we've done some of the initial cleanup, but now if we went and just tried to repair holes, you're going to get just a gnarly proposal. Everything's going to be distorted and not matching up correctly. And so what I'd like to do is not have to come in here and then trim vast amounts of my boundary just to get a smooth edge to it. You know, you could do that, but then you've lost a ton of your anatomy on this model. So let's undo that. And what the bridge tool allows us to do is to maintain a lot of this anatomy that we've got and then just fill in and repair the areas where we need to repair them. So if I go now to bridge, we can close that in, and now we've created a bounded hole so that when this repairs, it's going to just repair this little individual boundary, but the outer edge here is more or less a continuous edge. And we could just repeat that on all of these areas where it's troublesome. So once again, select an area, bridge it. I'm going to do the same down here. Now a mistake I continually make is that I'll fail to clear the selection, and so now when I go back up here and try to bridge again, you get this error because it doesn't know what you want to bridge. Is it this to this to this, here to here? So you need to always, between bridging, you need to always delete the last selection that you did because you only want two surfaces selected when you're bridging. This is a really prime example of where you would need a repair, because what are you going to do? Cut away all of this area and lose it? Obviously you don't want to do that, so let's just close that in. So edit, bridge, we've closed that. If you worry about this not filling in completely, then you could capture another area, edit and bridge. So we're just going to go around the model and perform this on any of the boundaries where they're rough and they need closing in. Can accept that. Great example here. Okay, so you get the idea. This was a really rough scan, And by bridging all this, now I can go to Analysis, Inspector. I don't want to close in the bottom of this model, so I'm going to just select each of these individual holes in the mesh to repair. So I don't want to click this one right here because that would try to close in the bottom, which I'm not trying to do right now. And there you have it. Now you have a mostly repaired model. If you do need to smooth up any areas where the bridging maybe created a rough surface, then you can just come in now with your brush tool, smooth out those areas. And now with most of that smoothed out, I can just select the outer boundary. I can expand the ring a time or two, smooth the boundary, accept that, and then I push T for transform. This is only if you do want to close that model in. And I usually pull it a long way down here so that I've got plenty of surface to plane cut. And finally, we can close this model by just doing a plane cut across that bottom. So wherever you want to enclose this model, just make a plane cut across that. We want to discard the bottom half. And here you see that that's a nice flat model. So everything is closed in, and we didn't have to sacrifice areas of anatomy. We filled those things in and maintained every bit of anatomy that we possibly could from the scanner. So anyway, you'll find plenty of uses for this tool as you begin to play with it, but those are just a couple that I thought I'd show you.